Yes. Now it's okay. Okay. I think voice is a problem. No problem. So once again, I welcome you in this session. I am Pragyabrat Tripathi, faculty, Department of Mechanical Engineering. So what is the motivation of, I will already told that, what is the motivation of this series? The motivation of this series is to enhance your GATE rank. Why? What is the main advantage of this one? Why? Because I think voice is no problem. Why? Because see, my dear, from here we discuss the shortcut trick. That means you can able to solve the problem within very few within very few. Okay, hello everyone. Within very few times. And along with that, what is the inside the concept behind each and every problem. So this is the very simple problem. It starts with this one. So this is the very simple problem which is asked in the department 2023. The department is civil engineering. Okay, beta. What is that question? This is a very simple problem. That means this is the basic questions. If you don't know, you don't know the fluid mechanics. Okay. So these are the pressure measurement device. You know that this device is a YouTube device. Okay. This is like a YouTube device. Okay. Now what is the question? It says that the pressure in the pipe. So there is a pipe which is like that. That means the pipe is look like a cross-section view. That means when this look like a cross-section view, when the pipe is perpendicular to the board. That means this is your pipe which is perpendicular to the board, and in this pipe the fluid is flowing. The fluid is flowing. So the fluid. So what is the motivation of this YouTube? The motivation of this YouTube is to measure the pressure of the flowing fluid in the pipe. Okay. So this is the pipe and the location is X. X is the location, and we installed a YouTube manometer. Okay, number first. Number second, what is that? In the YouTube manometer, one fluid is fixed like a manometric fluid. And that manometric fluid, we usually the mercury. Why we are usually the mercury as a manometric fluid? Why? Because it's have some properties, fluid property. What property? You know all the things. Okay, so these are the mercury. Okay, why? Because it is a low vapor pressure. The main advantage to use the mercury, it have a very low vapor pressure. You know these things. Okay, we'll already discuss in the classes. So there is a fluid. So this fluid is flowing, and that fluid is fluid labeled A, and that is the different color, light color, and there is a dark color of a mercury. And all the reference datum, all the reference height from the datum, it is given in the centimeter. Okay. Now, what is that? The pressure in the pipe at X, we have to find, is to be measured by open manometers. Why? Because open. Why? Because this end is open. Open, that means it is open to the atmosphere. Open to the atmospheric as shown in figure. Fluid A. What is the fluid A? Fluid A is the oil with a specific gravity it is given. Okay, its specific gravity is given. And fluid B, obviously fluid B is the manometric fluid, and generally the manometric fluid used in the mercury. Why? Because it's a low vapor pressure with the specific gravity. You always remember this manometric specific gravity 13.6. The absolute pressure at X, we have to find the absolute pressure X. The pressure have a different measurement, gauge pressure, absolute pressure, vacuum pressure. Okay, like that. So we have to measure the absolute pressure, and they are given the round of the 1 decimal place. So you have to correct up to 1 decimal place. What is that? The density of the water, you always remember. This is 10 to the power 3 kg per meter cube, and the acceleration due to gravity, it is given. If it is not given, you can assume 9.81, not 10. Okay, and the atmospheric pressure along with the atmospheric. Why the atmospheric pressure it is given? The atmospheric pressure is given. Why? Because this tube is open. This tube is open. Okay, so the manometric fluid is given. Now we have to solve this problem within very simple. So we have to select a reference datum line. See, the student get confused here. Ki, sir, where we have to select the difference datum line? My dear, you can select anywhere. Either this line, either this line, either this line, or either this center from this one. No problem. At any line. From your convenience, we have to select this reference datum line here. So this is the reference line A. Generally, we have to select the reference line at the meniscus. From it is passed at the meniscus. So this is the meniscus. Why? Because this fluid is different and this fluid is different. So this is the separation. That is called meniscus. Okay. So we have to select. Now from we know that from the Pascal's law, at the same horizontal line, what is the pressure due to this tube is the same pressure at this point. So we have to equate the pressure in the right limb and in the left limb. This is called left limb, this is called right limb. We equate the pressure. So very simple. Very simple. What is that? See, we equate the pressure. We have to draw the diagram first very quickly so that you have to solve. So this is your, okay, this is your pipe. No problem at all. So this is your pipe. This is your pipe, okay. This is your pipe, and it is connect with the U-tube manometer. Connect with the U-tube manometer. So this is your U-tube manometer. Connected with the U-tube manometer. This is your U-tube manometer, and it's, I think it's arrangement like that. It's arrangement like that. Okay. It's arrangement like that. Okay. It's arrangement like that. This is our arrangement. Okay, very simple. This is our arrangement. Okay, now here the pressure is X. Here the pressure is X. Now all the dimension it is given. All the dimension it is given. What is the dimension it is given? This is X. And here, from here, this is your manometric fluid. This is your manometric fluid up to this level. Okay. So, and all this, there is a fluid, that is oil is there. This is oil is there. In this also there is oil, same fluid is there. Now the difference, this is oil A, and this is your Hg, mercury B. No problem at all. This center distance from here, this is a here. Here we have to measure this meniscus. This meniscus from here to here. This is 75 centimeter. 75 centimeter, and this is your 25. This is your 25 centimeter. Okay. Now we have to equate the pressure. That means all the specific gravity it is given. Oil specific gravity it is S is given 0.8, and this mercury specific gravity is given 13.6. No problem at all. Now, so we equating pressure. Equating pressure. This reference line AA dash, pressure at AA dash. So this equating pressure is due to the same horizontal level. That means it is a Pascal's law. What is that? This pressure is atmospheric pressure P naught. So we have to take this equal to this. Pressure at this level is equal to same level, horizontal line. So pressure at A is equal to A dash is equal to pressure at A. This is the pressure at A. This is pressure at A dash. What is the pressure at A dash? First atmospheric pressure P naught. And we have moving along the G direction. When we are moving along the G direction, always add plus density of Hg. This is your Hg. Density of Hg rho G into H. H it is in centimeter. Convert into meter. 25 by 100. So this is at here. We have directly we have to jump here. We have to jump here. So we have to pressure A. What is the pressure A? This is your Px. 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 This is your, so here it is Px. Here it is a pressure Px, same horizontal level. Now we have to move upward. That means we have to move in opposite direction of G. Put the negative sign. So we are moving in the oil. So this is oil, rho G, and what is the height? We have to move 75 by 100. That's it. That's it. So we have to solve this one. This pressure P naught, it is given in kilopascal. So 101.3 kilopascal, convert into pascal, 10 to the 3, plus density it is given 13.6 into a specific gravity, it is given 13.6 into 10 to the power 3. Why? Because this is a density and there is a specific gravity given. A specific gravity is the density of the fluid divided by density of a standard fluid. So what is the density of a standard fluid? A specific gravity into density of water into 9.81 into 25 by 100 is equal to Px, density of oil, a specific gravity 0.8 into density of water 10 to the power fluid, a standard fluid 9.81 into what is that height 75 by 100. If you solve this one, the pressure at X is equal to 140.53 cross 10 to the power 3 Pascal. This is your Pascal. So convert into kilopascal. So this is your 104.53 kilopascal. And the kilopascal unit is what? Kilonewton per meter square. That's it. Very simple problem. That's it. Okay. Very simple. That's it. Okay. Done. Now we have to move. So this is the first question of the civil department, and that are the simple problem of pressure measurement device. This is the chapter in pressure measurement device. So when you have to revise the fluid mechanics, please try to solve such type of problem. Very simple problem, not very lengthy. Very simple problem in the fluid mechanics department. I am talking about the fluid mechanics department. You try to solve very simple problem. You install the manometer, how to calculate the pressure. That's it. Okay. Now next. This is the very good problem. Why this very good problem? Why? Because in this problem there are different method, but I am telling you, if you solve by the there is one method is the pressure prism method. So if you solve this problem with the pressure prism, you can easily find the and very convenient of the solution. Okay, so we have to try to solve by this question with the pressure prism device. Okay, pressure prism method. What is that? This is the mechanical engineering. Stream is mechanical engineering 2023. Generally, what is my observation is, as a faculty, the fluid mechanics in the mechanical department and fluid mechanics in the civil department, generally the fluid mechanics with respect to the mechanical department is little bit tricky and tougher as compared to the civil department. Why? Because in the civil department there is also second part of the fluid mechanics known as open channel flow. So you are more focused on the open channel flow as a civil engineering, and mechanical engineering you focus about the very strong concept behind the fluid mechanics hardcore subject. Okay, for the mechanical. So this is for the mechanical. What is given? This is your figure. So what is the figure given? There is a one of the plate. It is the plate like given, and that plate holds the fluid. So this fluid is in a static manner. Let's suppose. So this question is asked in the fluid static chapter. So fluid static chapter, you have to solve such type of problem so that you can easily find what they are asking. So the figure as shown in figure, the figure shown two fluid. There are two fluid is that. Two fluid, it is visible? Yes. Two fluid held by the hinge gate. So these are the gate, and this gate are hinged. That means at this point, the gate will try to swivel around this point. Okay, hinged gate. The atmospheric pressure is given. That means at this point, the atmospheric pressure is given how much? 100 kilopascal. No problem at all. Okay. The moment per unit width, that means the width it is you have to take 1. If not is given, no given, you have to always calculate the calculation per unit width. Okay, so width, it is a perpendicular to the board, and width, why we have to neglect the width? Why? Because it is so long in the perpendicular direction, so that we can neglect other than the effect. Okay, so this width we can neglect, which is perpendicular to the board. The moment per unit width about the base of the hinged is what? This is NAT based question. NAT is what? Okay, in which unit? Kilonewton meter. See, this is kilonewton meter. This is what is this? Kilonewton meter. This is the moment. Force into perpendicular distance divided by meter. Why divided by meter? Why? Because it is asking force per unit, force into distance. This is force into distance divided by the width. That is the unit is here. Okay, round off to 1 decimal place. That means you have to correct up to 1 decimal place, and taking the acceleration due to gravity is 9.8 meter per second. Okay. All the parameters according to the question is given. The fluid 1 have, let's suppose this is the density, it is given, yes, kg per meter cube, that means this is a water, obviously 1000, that means it is a water, and this is 2000, this is the 2000, that means kg per meter cube. This is a heavier density, this is a lighter density, so it is a downside. So it is, I think it is a mud type like that. There is a mud, yeah, any heavier density as compared to water which is below, and the height of this heavier fluid is up to 2 meter from the free surface, up to 2 meter, and this height of the water, approximately it is a water, is up to 1 meter from the free surface. So we can solve this problem. We can solve this problem with the help of pressure prism. Okay. Now you can also solve by this different method. There are different method. We have to already discuss in the classes what is the different method for that finding the hydrostatic force. So this is the question related to the hydrostatic. Okay. So we have to solve this problem. Very good. This is a very good problem. Beta. What is that? See, we have to solve this one. Okay, we have to solve this one. What is that? So this is your plate is there. This is your plate. Okay. This is your plate is there. Now, at this plate, there is a reference datum, you can assume like that. At this point, on the left side, we have to draw the pressure prism, pressure diagram. Okay. Now, this is your plate, and at this point, up to this one, okay, okay. So here, up to this one, there is a one fluid. Here, up to this one, there is another fluid. There is a two fluid is there. Okay, there is two fluid there, fluid A and fluid B. Right. Okay. Now, this is your free surface. What is the free surface? Please tell me, beta. Anyone? What is the free surface? What is the free surface? Anyone? You know that? What is the free surface? What is the free surface? The free surface, it is the surface on which there is no any tangential stress. There is no any tangential stress. And there is no any tangential force, you can say that. That means if there is no any tangential force, that means the shear stress 0, only the normal force will act. That is called the characteristic of the free surface. So this is the notation of the free surface, reverse triangle, and below the triangle there are three lines. So this is the notation of the free surface. Right. And this height is your h1, and h1 height, it is given how much it is? It is given 1 meter, and this is your h2 height. And what is your h2 height? It is given 2 meter. Clear? This is the different fluid, this is the different fluid. Okay. This fluid have a density rho 1, 10 to the power 3, and this is rho 2 of 2000. This is given. Okay. Now we have to draw the pressure prism. Okay. So my dear, you know this. The pressure variation below the depth is your linear relation. Okay. That means at this point, if you draw, okay, this is a vertical plane. Now, if you measure the pressure, this atmospheric pressure is constant throughout. So let's suppose the atmospheric pressure, we have to neglect the effect. Why? Because the atmospheric, what is the pressure due to the atmospheric pressure? They are the same throughout. Okay, so we have to neglect, we have to assume like that. Here the pressure is 0 with respect to 0. There is not a pressure 0. There is atmospheric pressure. But we are talking about in the gauge sense. So when we are talking about in gauge sense, the atmospheric pressure is 0. Now, the pressure is variation. This pressure is variation triangular manner. Okay. This pressure is variation in the triangular manner. So in the triangle. Okay. Like that. Again, it is like that. Okay, so these are the pressure variation. Now, my dear, now these are the pressure variation. So this, see, this is one triangle and this is a trapezium. So this trapezium, we have to convert it into, first is, so there is one rectangle and one triangle. Okay, like that we have to take this one. Okay, this is okay, no problem. Now, this height, so my dear, why we have to take, what you have to say that, Vita? Sir, I am prepare fluid mechanics and hydraulic machine from R.K. Rajput book. It have lots of a problem. This problem will be for the gate. Yes, this problem. What you are asking, Vita? Yes, this is the problem related to the gate, Vita. Others, sir, I am preparing fluid mechanics. Yes, okay. R.K. Rajput, heat transfer and deviate incorporate. Heat transfer. Like, see, Beta, I am telling you. Acha, first tell me, you are so you are talking about the heat transfer. That means you are a mechanical department. My dear, for the mechanical, you have to follow the book S.K. Som, not R.K. Rajput. S.K. Som. You have to follow the book S.K. Som. Okay? S.K. Som is very good book. And for the heat transfer, you have to follow the Yunus and Senjal. That is the book. Okay? So S.K. Som you also easily available in your library, college library. And for the heat transfer, you have to solve the problem of Yunus and Senjal. Okay? Thank you. So why we have to, there is a one thing is that, why we have to draw the rectangle part here? Why? What is the concept? Sir, why? There is a triangle is there is no problem. Why we have to draw the this green line? My dear, what is the reason is that? This is the pressure. So on this fluid, if you measure the pressure here, if you measure the pressure here, the pressure effect by this fluid also. So what is the pressure here at this point? What is the pressure here is due to the pressure of this fluid. And what is the pressure at here is due to the pressure of this fluid plus this fluid. So at the pressure here, this pressure is for which fluid? 1000 fluid. So this 1000 fluid is the pressure, okay, at this point, plus the pressure due to this 2000. So the pressure due to 2000 must be higher as compared to pressure due to the 1000 fluid. So pressure due to the 1000 fluid and pressure due to the 2000 fluid. So pressure due to the 2000 fluid is include the pressure due to the 1000 fluid. So this is the pressure due to 1000 fluid and this is the pressure. So this is the total pressure of the 2000 fluid. That's why this is the, why we have to draw the rectangle. That rectangle is the effect due to the 1000 fluid. Sir, full scale model? No. Ardari, we have to discuss with this problem. We will not go to detail, okay? If you have any problem, please comment on this one. I personally verify your comment and I'm damn sure that I will do the comment on same answer. What you want, I will discuss. Otherwise, we have a 1 hour span. We have to discuss all the things, okay? Others, I hope you are convenient for this one. If you have a problem, write your comment. After the classes, I will, okay? I will discuss with this one. Okay. So this is your, okay. Now we have to, so this is 1, 2, and this is 3. So there are 3 things. Now this 1 is the pressure, is F1, and this F1 is the horizontal. This is your F1. Okay, let's suppose this is your F1. On this one, there is F2. There is F2, F3. This is your F3, and on this rectangle there is F2. So this pressure, beta, this hydrostatic force, this force is on the CG of this triangle. Mind it. This force, let's suppose this is your F1. This F1 force is the CG of this pressure triangle. This F2 force is your CG of this rectangle. This F3 force is your CG at this triangle. So we have to mention A, B, C, D, E, and F. So my dear, this is your force, hydrostatic force exerts on the plate. These are the hydrostatic force exerts on the plate. This force is the CG of this triangle. This F2 force is the hydrostatic force which is exerted on the plate, and this is the F2 force is the CG of this rectangle, and this F3 force is the hydrostatic force of this 2000 fluid which is act at a CG of this second triangle. Okay. So we know that this F1, if you have to measure the height, beta, if you have to measure the height F1, so this is your F1 from this base, this is your F2 from the base, and this is your F3 from the base. Why we have taken from the base? Why? Because beta, here is the hinge is there, and we have to find the moment at this point. So we have to take the moment at base. So we have all the measurement from the base. So what is the height? So F1 is the total triangle. F1 is the total triangle. So what is the center CG of? So F1 is from the base. What is that? From the base, what is that, beta? See this one. If you take this CG of triangle first, so if you take the triangle first, what is the CG? What is the CG? Why? Because this is the triangle first CG. So what is the CG? The CG is from the base is h by 3. H by 3. What is h? 1. This is 1 by 3. So this is from here to here 1 by 3 plus 2. This is 2. So 1 by 3 plus 2 is 7 by 3. So from this one, from this to this height is your 7 by 3. So this is your 7 by 3. It is clear, everyone? It is clear, everyone? It is clear. Why? Because see, if you take this triangle, what is the CG of this triangle from the base? H by 3. So what is h of this triangle? Is 1. So 1 by 3. So 1 by 3 is from this distance to this distance. Remaining is distance is 2. So 1 by 3 plus 2 is equal to, that means 1 by 3 plus 2 is equal to 7 by 3. Clear? Now, what is the CG of this one? What is the CG of this rectangle? Obviously, this is your, what is that? This is your 2. That means this rectangle, this is your 2. So this is your 1 meter. 1 meter. This is your meter. And what is the CG of this last triangle 3? What is the CG? H by 3. What is H? 2 by 3. 2 by 3 meter. Clear? All the dimension we have to find from the base. That means from this point. Now, we have to find, so this is the first, now we have to find F1, F2, F3. So we have to find F1. So what is F1? This hydrostatic force is nothing, it is the volume of the pressure prism. It is the volume of the pressure triangle. That's it. What is the volume of this triangle? AED. That means area of triangle AED into width. And width we have to take 1 meter, unit width. So what is the area of the triangle? Half into height. What is the height of this one? 1 into what is the base here? This base is, what is that? DE. So if you write like that, this is your half into AD into DE into width. Yes or not? This is the volume of this triangle. So half, what is AD? What is AD beta? AD is 1. What is DE? So DE is, this is a pressure prism. This is a pressure triangle. So what is the pressure at DE? Rho. What is rho? 1000. Rho into G, 9.81 into height. What is the height? 1. So this is your, this quantity. This is your DE into width 1. Clear? So if you solve this one, this is your 4905 Newton. No problem at all. Now what is F2? F2 is the area of rectangle, which one? DEFB. DEFB into width. So what is the area of this rectangle, beta? What is the area of this rectangle? Height. That means DB into this width BF. So this is your area into width. Okay. What is DB? DB is your 2. My dear, this BF is equal to DE. Yes or not? This BF is equal to DE. Yes or not, beta? So what is DE? 1000 into 9.81 into 1 into width is 1. So this is how much? Just double. 39240 Newton. Clear? Clear? Now, what is the force F3? F3. F3 is equal to area of triangle ECF into width. Okay. What is the area of the triangle? Half into this EF into FC into width. So half. What is the CF, beta? CF. What is the CF? What is the CF? This pressure. That means half this one. This one is what? Triangle. So this one is what? EF. EF is what, beta? 2 into CF. CF is what? CF. The pressure is here. So pressure rho, that means 2000 G into what is the height? 2. So this is your FC. This is your FC. Okay, na? This is your FC. What is the FC? Pressure at here. What is the pressure here? Rho. What is the rho here? 2000. G 9.8. And what is the height of this triangle is 2. Put 2 here. Into width is 1. What is this value? This value is 49. No, it is not like that. 1 second. The calculation mistake is there. This is the calculation mistake. This is your F2. F2, it is your 19620. 19620. F1 49 2 1960, and this is your 39240 Newton. So we have all the forces. We have all the forces. So this is our plate at this point O. Here is the force. It is all the forces we have. F1, F2, F3. Yes or not? F1, F2, F3. Okay. So F1 we have from the base. This is your 7/3. This is your how much? 1, and this is your 2/3. Take a moment at point O. So we have to find static equation. Summation of all the moment at point O is equal to this force F1 into 7/3 plus this force F2 into 1 plus this force F3 into 2/3. Put all this value, your answer it is 57.22 kilonewton meter per minute. Clear? This is clear? Okay now? Now, we have to take the next problem. Why? Because the time is very less. Time is very less, beta. Now, this is the very good problem. Damn sure this is a very good problem, beta. Very good problem. In 2023, mechanical, this is a very good problem is there. What is that? Consider a unidirectional fluid flow. Unidirectional, that means one direction. Unidirectional, that means one direction. That means either X or either Y or either Z. Fluid flow with a velocity field it is given. This is the velocity field V, X, Y, Z into T. This is the space coordinate, this is time. Is your unidirectional, that means one is V, X, T into I. Okay. That means other one is 0. It is visible? Yes. Other one is 0. That means this is 0 plus 0. So this is your V component, this is your omega component. Is 0. Okay. Where U at X and T is 1. It is given. If the spatial homogeneous density varies with time, that means the density is vary with respect to time. This is time. With respect to time, it is given. So the value of the velocity at the location of 2 That means x will changing at a location 2 and the same time, that means a time is equal to 1 second, let's suppose, is what? That means you have to find the velocity, that means you have to find the velocity of a one directional velocity u component, not v and omega. Why? Because v and omega is 0 at a location x and at a time is 1. At a location 2 and a time is 1. So at this point, what is the velocity? And the density is varying with respect to time. That means this is the unsteady flow problem. This is the unsteady flow. So when you have to find the velocity, from which equation you have to find? So there in the fluid mechanics, there are three equations. First is the conservation of mass. Second is the conservation of momentum. Third one is the conservation of energy. Conservation of mass is the equation guided by the conservation of mass is known as continuity equation. The conservation of the equation guided by the conservation of momentum is the equation is two equations. One is the Euler's equation, other is one is the Navier-Stokes equation. And conservation of energy, the equation is guided by the Bernoulli's equation. So there are four equations is there. One is the continuity equation. Second one is the Bernoulli's. Second one is the Euler's equation and Navier-Stokes equation, and third one is the Bernoulli's equation. So Navier-Stokes equation and Euler's equation, these are based on the force equation. That means conservation of momentum equation. And the continuity equation gives the conservation of mass. So from the conservation of mass, we have to derive the continuity equation, and from the continuity equation, we can find velocity. So this question is related to the fluid kinematics. This question is related to the fluid kinematics. Okay. So this question is related to the fluid kinematics. How to solve? This is very important. So beta, given, what is given here? Velocity vector, it is given. It is in x, y, z and t time. This is the velocity field, and it is generally ui plus vj plus omega k, and u is a function of x and t. That means this u, what is u beta? U is the function of x and t. V is the function of y and t. Omega is the function of z and t. So these are the unidirectional. So this is 0 and this is 0. So the u it is given is the function of obviously x and t is I direction. So this velocity vector, velocity field x, y, z, t, it is given. It is given in the question. Correct? Now, and also it is given u at origin x is equal to 0 and at any time the velocity it is given 1. We have to find u at 2 and time is 1. What is the value? And during the fluid flow, the density is vary, and density relation is the function of time unsteady, and this is given. What is the given beta? 1 plus 0.2 e to the power minus t. This is given. Now, what is the continuity equation? Continuity equation. So first strike in your mind what is the equation is applied. So what is the continuity equation? We know that dou rho by dou t plus del dot rho v vector is equal to 0. This is the continuity equation. okay, in the vector form. In the vector, this is a del operator. How to operate this one? How to operate? This is your del operator and this is your velocity vector. And this is given. This is given. This velocity vector, it is given. What is given? U and IV. Now, how to split this equation? We have to split this equation dou rho by dou t, and this is a del operator in the vector form, plus dou by dou x rho u plus dou by rho v plus dou by dou z rho omega. This is equal to 0. Now, my dear, here u and v is 0, so this and this will cancel, not applicable. So, what is the equation is there? Dou rho by dou t plus this is the function of time only. Time only, that means unsteady. So, we have to take, and this in this variable, this is the function of position. So, with respect to the function of position, that means this is your unsteady uniform. Unsteady uniform. So, for the uniform density, u is equal to density dou rho by dou x is equal to 0. So, according to the given condition, this is our the continuity equation. This is our the continuity equation. So, we have to put all this value here, put density, put the value here, all this value. Put this value here, that means rho by, that means dou by dou t, and what is the rho beta? Rho is the function of time, 1 plus 0.2 e to the power minus t plus density 1 plus 0.2 e to the power minus t into dou by dou u by dou x is equal to 0. So, if we solve this one equation, so from here, if you solve this equation, differentiate this one, so from here you can easily find dou u by dou x 0.2 e to the power t divided by 1 plus 0.2 e to the power minus t. Correct? So, this is dou u by dou. That means this is your acceleration. This is your local acceleration. Okay, so acceleration, there are two parts. One is the temporal, other is a local. So, these are local with respect to x. So, now we have to find the velocity. Why? Because the velocity at a point of 2 and 1 you have to. So, if you find the velocity, just integrate. So, integrating. So, we have to integration. What is the integration? U is equal to 0.2 e to the power t. This integration with respect to x. So, this is constant. 1 plus 0.2 e to the power minus t into integration of dx is x plus c. Now, we have to find the c value. For the finding of c value, that is given. What is the given, beta? What is the given? X is equal to 0 at any time t, u is equal to 1. What is this value it is given? X is equal to 0 and u is equal to 1 at any time t. So, put x0, u1, find c. So, x0, so this is 0, u1, so c is equal to 1. C is equal to 1. So, put this one, so u is, so now u is your 0.2 e power minus t divided by 1 plus 0.2 e power minus t into x plus c is 1. Now this is your expression. Now we have, this is the function. So obviously this function, this u is the function of x and t. That means this u is the function of x and t. This is equal to 0.2 e power minus t divided by 1 plus 0.2 e power minus t x plus 1. This is your velocity. Put the value here. That means you have to find u at 2 and 1. So this is your 0.2 e power minus 1 divided by 1 plus 0.2 e power minus 1 into x. X is your 2 plus 1. So if you solve this one, this is your approximately 1.137 meter per second, approximately 1.14. Clear? This is clear? So according to this one, we have to find this value. So this is the very good question along with the fluid mechanics, and also there is the mathematics is there. Also there is a mathematics is there. So my dear, please be careful. For the mechanical student, you have to solve with the continuity equation. That means you have to deep concept about the continuity equation, or in the form of vector and also in the form of Cartesian coordinate. Not cylindrical and spherical. You don't bother about that. Okay, sir, we have to also understand. No, it is not required for the understanding of the continuity equation in the spherical coordinate or a cylindrical coordinate. That means we have to not much more focus about the polar coordinate, only in the rectangular coordinate and also in the vector form. How to apply, find the density, how the density variable, you have to solve such type of problem. So in this zone, the such type of problem they may asked. Clear? Now we have to take a next problem. This is, also this is the very good problem is there. This is a very good problem for the mechanical. What is that? A velocity field in the Cartesian, and this Cartesian coordinate, it is given in two-dimensional flow. Yes or not? Two-dimensional. Why? Because see, this x and y it is given. Two-dimensional flow, and what is the value it is given? K xi in minus yj velocity is given, and where k it is given per second. It is given the constant. Coordinate x and y are in meter. Assume the gravitational effect is negligible. That means we cannot take the gravitational effect. Very important thing is there. That means acceleration due to gravity you can take 0. And the acceleration due to gravity is more responsible to the potential energy. That means potential energy we have to take neglect in this case. Why? Because potential energy is mgh and g is your negligible. So we are not bothering about the potential. Now, see my dear, if the density of the fluid it is given and the pressure at the point, there is a one location. Let's suppose there is a location, A. And at this location, this is origin. Origin is anywhere. We don't know that what is the origin. A point, and A is the location, and at this point the pressure it is given 100 kilopascal. Find the pressure at the location, that means at a point B. What is the pressure? So my dear, this is the asking the pressure. When the asking is pressure, we have to apply the conservation of energy equation. For the conservation of energy, we have to apply the Bernoulli equation. Why? Because there is nothing says that the viscous is there or not. So we assume this is inviscid flow, and it will flow along the streamline, and that streamline passing through the 2 points. One is the origin, other is the 2, 2. One is the reference point, origin. Let's suppose 0, 0. So see my dear, what is the difference between these question and this question. This question is the kinematics, fluid kinematics. This question is related to the fluid dynamics. So, after reading the question, you have to feel the difficulty, कि sir, how to click this question, how to solve this question, what equation you have to apply. So, clue is there. Here you have to ask, here you have to find the velocity. Here you have to find the velocity. So, apply the continuity equation. Here we have a velocity, here we have the pressure, apply the Bernoulli equation. So, we know that the Bernoulli equation is applicable along the streamline. So, the streamline is passing between the origin and this location. Now, my dear, that means that is your coordinate, two-dimensional, only two-dimension is there. This is your coordinate, okay. So, this is your x, let's suppose this is y and this is your x, okay. This is your origin, let's suppose this is your origin and this is a 2 meter and 2 meter, there is another point. So, let's suppose this is your 1 point and there is a 2 point and here the streamline is flowing. Let's suppose this is your streamline. From this point there is a streamline is there. Okay. So, along this streamline, this is your streamline. Streamline. So, at this point, let's suppose 0, 0 and at this point, let's suppose 2 and 2. These are the meter and this is the flow. These are the flow in this direction. Okay. So, we have to apply the Bernoulli equation between these 2 points. What is the Bernoulli equation? We know that P1 plus half rho V1 square plus potential energy, which is negligible, 0, is equal to P2 plus half rho V2 square plus potential energy, which is negligible. Why? Because there is no effect of gravity. The potential energy is negligible. Why? Because according to question, Z approximately 0. There is no effect of Z. So, we have to neglect the potential energy. Now, my dear, if you apply the Bernoulli equation, so we have to find the pressure P2. We have to find the pressure P2, but and we have a knowledge about P1, but we don't have a knowledge about V1 and we don't have a knowledge about V2. So, to find V1 and V2, so V1, there is a velocity, here is the velocity, here is the velocity, which is V1, here is the velocity, which is V2. So, we have to find V1 and V2. So, we have an equation, that means V is equal to K xi minus yj. This is given. So, if you find V1, K and 1 it as origin 0i minus 0j, that means this is 0. That means velocity at this point is 0. That means no potential energy, kinetic energy. Now, velocity at point 2 is equal to K. K is what beta? 2. So, 2 into 2i minus 2j. So, this is your 4i minus 4j. So, if you find the velocity vector, this is a velocity vector V2, just a square root 4 square plus 4 square. So, this is your 32. Okay, this is your 32. So, what is the V2 square? V2 square is your 32. We have to put this V2 here. So from this one, P1 it is your 100. P1 is what beta? P1 it is your kilopascal. Convert it in Pascal. So 100 into 10 to the power 3. Velocity is negligible. Is equal to P2. We have to find it plus half rho. Density it is given 1000 fluid. So this is 10 to the power 3 into velocity is what beta? 32. 32. Velocity is what? 32. So if you have to find this one, half rho 10 to the power 3 into 0. This is 0. So P2 plus this is your 1600 is equal to this is your 100 per power 103. So P2 is equal to 8400 Pascal. That means 84 kilopascal. This is simple problem. Calculation is simple, but the concept is very important. Ha, Pratik. Concept is very important. What is the concept is there? So let's see this equation. This is your question, but in this question, which equation is applied? That is your mind. That is your practice. Number first. Number second, read this question and what is the equation is applied. But in the throughout the fluid mechanics, there are three types of equation: conservation of mass, conservation of momentum, and conservation of energy. So conservation, if you find the velocity, why? Because in this question, they are asking that what is the velocity at a coordinate 2 and 1. So when you find the velocity, that means it is the categories in the kinematics, and when you find the kinematics, you have to apply the continuity equation. That means conservation of mass. Clear? So in this one, we have to apply the continuity equation. Along with that, we have to solve the velocity. But in this question, they are asking the pressure at the location. So pressure, it is the pressure in which content the pressure is related. The pressure is related in the conservation of energy. That means a Bernoulli equation. So in this case, we have to apply the Bernoulli equation. Mind it, beta. So right now, in the pattern of the gate, they are not supposed to directly give the indication that we have to apply which equation. So for the conservation of mass, conservation of momentum, and conservation of energy. So conservation of mass, where it is applied, conservation of momentum, where it is applied, and conservation of energy, where it is applied. That is the very important. This must have to be understand about that. Why? Because they are not directly says that find according to the Bernoulli equation. These are your mind. So the velocity, so it is not directly in the previously before 2 and 3 year, past 2 and 3 year, 5 year, the velocity is given, pressure is given, all the things is given, you have to directly apply. No, it is not like that. The velocity now it is given in the field form. That means when the question is asked, they are also check the kinematics concept. Okay. So it is not the velocity it is given, it is the velocity in the vector field. So beta, the equation in the conservation of momentum, conservation of energy, and conservation of mass, all are in the form of vectorial. You must have an approach. That means the question which is asked in the fluid mechanics is a vectorial approach. So you must have a read about the vectorial approach, and that vectorial approach always in the Cartesian coordinate. You are not supposed to be asked. That means you don't think that the other than the Cartesian. No, it is the polar coordinate and Cartesian coordinate. So always stuck with the Cartesian coordinate. In the Cartesian coordinate, it is very important. So what is the Cartesian coordinate? So in the vector form, what is the continuity? This is the continuity equation. Dou rho by dou t plus del operator of rho v vector. So this is the precisely the continuity equation in the vector form. If you split this one, this is the things. If you split this one, this is the things. Okay, so right now this is the pattern of this question, beta. It is not like that they are asking. So what is the equation? So in the fluid mechanics, the conservation of momentum, there is a inviscid or viscous. Inviscid, Euler's equation, viscous, Navier-Stokes equation. So the Navier-Stokes equation also there is a question will ask in the vectorial form. So please 2 marks question always asked in the GATE examination. Damn sure, by because right now the IISc Bangalore is question conducted the GATE. So in this one must be a strong calculation in the vectorial form. Vectorial form is a very important. So please try to solve all the problem in the vector approach. Del operator, curl, divergence, like that, and you have to apply. That means it is not directly given, beta. I'm telling you. Okay? Now, we have to solve the next problem. What is the next problem? This is the next problem. This is also the mechanical. There is a T, but it is not T, it is a tau. What is the given? Air. The fluid is air, not liquid. The fluid is in the gas. The density it is given. Beta. And kinematic viscosity it is given. The kinematic viscosity, the parameter is, the unit is always kinematic terms. Flow over a flat plate. That means this is the question related to the fluid dynamics, and that flow is an external flow. So beta, in the fluid dynamics, in the fluid mechanics, we have to encounter with the situation of a two type of situation. Number first, flow passed over the body and flow inside the body. Flow passed over the body known as external flow. Flow inside the body is known as internal flow. What is the example? Flow over the flat plate. It is the external flow. Flow within the tube. It is the internal flow. So this is the question related to the external flow. This is the question related to the external flow. What they are asking that? A flow over a flat plate with a free stream velocity. Free stream velocity, that means u infinite, it is given. The wall shear stress at the location. See, if there is a wall we have to locate location. So there is a wall. If the fluid is flowing in this direction, so this is your leading edge and this is your trailing edge. So location at 50 mm from the leading edge is tau w. There is a wall shear stress. They are asking what is the shear stress at the location of 30 from the leading edge. These are very, very common question. If you don't know, if you're not able to solve the problem, that means you are not able to know, you are not understanding the fluid mechanics. These are the problem which is a very, very common problem in the fluid mechanics. In the flow over flat plate, there is a some location. What is the effect? What is the flow effect of the another location? What is the boundary layer thickness? What is the displacement thickness? What is the momentum thickness at that location? What is the shear stress? What is the skin friction coefficient? All the things at a different location. How to calculate at the particular point? Always try to understand. Always try to understand like that concept. Otherwise, you have to lose the marks. What is that, beta? See. What is that? This is your plate. So, this is your plate. This plate is your edge view. It is not a plane view. This is your edge view. So, edge is given. So, this is your plate. Now, we have to measure perpendicular to the plate always y direction and flow along the plate. It is in x direction. Okay, and the flow it is in this direction. That is the fluid flow. That is the fluid flow. That is the fluid flow. Okay, this fluid flow with the free stream velocity u. Now, my dear, this is your leading edge and this is the trailing edge. Always characteristic. From this point to this point, let's suppose this is your x1, and from this point to this point, let's suppose x2. So, my dear, there is a x1, this is your x1, this is your x cross section. So, at x2 and x1, so x1 the stress is given. So, at the x1, the stress it is given, beta, x1 the wall shear stress is given, x2 we have to find the wall shear stress. We have to find the wall shear stress. My dear, I'm asking you a question. If we move from the leading edge to trailing edge, the shear effects are smaller and smaller. So intuitionally, as x1 distance, we have to draw a large magnitude as compared to the leading edge at x2. So if the flow it is in this direction, the shear stress of the wall will decrease. Okay? Now my dear, so this is your tau of x1 local, and this is tau of x2. Tau of x2. Now they are asking that this x1 it is given, how much it is given? 15 mm, and this x2 it is given 30 mm. Now beta, there is nothing it is given apart from that one, there is nothing it is given. That means we have to apply the Blasius equation. What is the Blasius equation? If there is no profile, nothing is given, so we use the Blasius equation. Now my dear, for the applying the Blasius equation, either it is in laminar flow or a turbulent flow, the Blasius equation is differ. That means the parameter which is outcome from the Blasius equation, that are the differ. That means if we have to check number first up to this length 30 mm whether the flow is laminar or turbulent. For the checking of the flow pattern whether the flow is laminar or turbulent, we must have to find the Reynolds number. This is the external flow and flow over flat plate. What is the critical Reynolds number? 5 cross 10 to the power 5. So we have to check the Reynolds number, local Reynolds number Rex at 2. Why? Because we have to find up to this point. So this is what beta? Free stream velocity x2 divided by kinematic viscosity. So we have free stream velocity how much? 2. x2 it is your meter 0.03 divided by kinematic viscosity is how much beta? 1.5 cross 10 to the power minus 5. If you solve this one, this is your 4000. And this 4000 is less than RCR. So the flow is laminar. The flow is laminar, external flow. Laminar external flow. External flow. This is your laminar and external flow. Now my dear, what is the Blasius equation? Wall shear stress, we always remember the wall shear stress is equal to at any location, wall shear stress at any location x, this is equal to 0.332 density U infinite square divided by root under Rex. Now you have a one question. Okay, sir, whether it is possible to remember? No, I am telling that you don't bother about the remembrance. You are only bother about the variable x. That means, see my dear, what is the Reynolds number? That means a Reynolds number, local Reynolds number is directly proportional to x. Yes or not? See this one. If velocity and kinematics is same, that means a Reynolds number is directly proportional to the distance of the plate. Now, if you put that, that means the wall shear stress, that means a wall shear stress at any location x is inversely proportional to root under x. Yes or not? This have to remember. This characteristic, what is the different characteristic I am telling you? The relation of x, and that relation of x with respect to the parameter, fluid parameter, that we have to define by the Reynolds number. So you have to always remember the relation between the boundary layer thickness CFX, wall shear stress. So this always remember what is the relation between these three in the laminar and turbulent both. Laminar and turbulent. So for the laminar and turbulent, what is the boundary layer thickness with respect to X? How to varies in the laminar? How to varies in the turbulent? What is the skin friction coefficient? How to vary in the laminar? How to vary in the turbulent? That means this, if you find, that means you have to find the function of X. What is the functional relation of X? What is the functional relation of X? So just now we have to see that for the laminar, the shear stress is a square root, inversely of the square root. Inversely of the square root. This have to remember, not this total formula. Don't remember. Don't remember. Always remember. Always remember. That means you have to know about the how the boundary layer thickness will vary along the plate direction, how to the skin friction will vary along the plate direction, along the direction of the plate, how the wall shear stress along the plate direction. That means the wall shear stress is inversely proportional. That means if you draw, and this is a laminar, the flow is laminar. So this is the boundary layer. This is a boundary layer. This is called edge of a boundary layer. This is called edge of a boundary layer. This is called edge of a boundary layer. And the flow over flat plate. Anyone ask you, if the flow over flat plate, what is the shear? Draw the shear stress diagram. So the shear stress diagram, if you draw, the shear stress diagram, if you draw, this is your shear stress diagram. This is your shear stress diagram. That means from the plate, the shear stress will decrease. Yes or not? The shear stress will decrease. See? And this shear stress decrement, this is the shear stress curve. That means the shear stress, local shear stress is inversely proportional to root under X. This have to remember. That means what is here the shear stress and what is the shear? So shear stress continuously will reduce. Okay, so we have to remember. Now we have a shear stress at this point, at this point, at this point, at this point. So we have to easily find for this one. So we have to find tau wall at 2 divided by tau wall at 1, and this is square root of x1 divided by x2 inversely. So what is x1? x1 is 15, x2 is 30. That means this is your 1 by root 2. So the wall shear stress at location 2 is equal to half of square root of location first. That's it. These are the option it is given. Wall shear stress is half of the, this is the tau 1. So half of the initial value. Half of the initial value. So wall shear stress at location 30 is half of the initial value. Square root of the, so option D is correct. Clear? So like that, you always remember this relation. Always remember this relation. In the turbulent and laminar, you are not remember like that this exact solution. No, we have not remember this exact point 3. If they are in the question related to this one, this relation always provided in the questions, no problem. But what is the relation of X? That means if you are moving from leading edge to trailing edge, if you are moving from the leading edge to trailing edge, what is the variation of delta? What is the variation of boundary layer thickness? What is the variation of local skin friction coefficient? What is the variation of local shear stress with respect to X in the form of laminar and in the zone of turbulent? And if the finding the laminar flow or turbulent flow, go through the Reynolds number. Flow over the external flow, external flow, the Reynolds number, if less than the critical value of the Reynolds number, that means 5 cross 10 to the power of 5, that means the flow is laminar. Clear? Everyone clear? Please tell me. It is clear, beta? Everyone, please. It is clear? It is clear now? Now, the next one is this problem. This problem is asked in civil department, but this is also with respect to mechanical departments, very important. This question is nothing, it is the conservation of momentum. This question asked in the conservation of momentum, that means momentum equation, fluid dynamics. That means particularly in the fluid dynamics, there is a one chapter, impact of jet. Impact of jet. So this question related to the impact of jet. And why this question is asked in 2023, I am also telling you. See, my dear, a jet of water having a velocity, that means water ensuing. How to develop a jet? The jet, that means a very high velocity, and that will develop with the help of nozzle. So from the nozzle, the velocity, it is 20 meters per second, strike a series of a plate. That means there is a series of a plate, and that series of a plate is fixed radially on the wheel. It is a like of a Pelton turbine. So there is a wheel is there. On the wheel, there is a series of a plate is there. Wheel revolving in the same direction of a jet, and the wheel speed, and that is the tangential speed, is your 15 meters per second. This is your nozzle velocity, this is your jet, this is your nozzle ensuing velocity, that means jet velocity, and this is your peripheral speed of the wheel. What is the percentage efficiency of the plate? This is very important. What is the percentage efficiency of the plate? What is mean by the plate efficiency? That means if you find efficiency of the plate, what is mean by this? What is mean by this one, beta? What is mean by this one? This question is telling about that. So first we will discuss this one. Let's suppose, beta, let's suppose this is your wheel. This is your wheel, okay? Let's suppose this is your wheel. On this wheel, there is a plate is mounted. On this wheel, there is a plate is there, beta. The plate is there. There is a one plate. 1 second. There is a one plate. Series of a plate. There is another plate. Series of a plate, beta. There is another plate. Let's suppose, and there is another plate. So it is look like a Pelton turbine. Okay. So these are the plate, series of a plate. Okay. Now the jet is strikes. That means there is a jet. That means this is your jet. 1 second. The jet is striking like that. Okay, jet will strike. Now, my dear, this jet strikes is the tangent of this circle. Is the tangent of this circle. So this is a tangential flow. This jet will strike at the tangent. That means this jet velocity. This jet velocity is your V, is your V. This jet velocity is your V or a V1, anything you can write like that, V. And from this jet velocity, this plate will rotate with a tangential velocity u. with a tangential velocity u. So u is the velocity which is try to rotate this wheel, okay. Now my dear, so this is your jet velocity and this is your plate velocity, yeah, wheel. So these are the tangential direction. Now beta, that means, very important, that means this is your input and this is your output. So the efficiency is output by input. Now my dear, now this input is issuing from the nozzle. So there is nozzle. So at the exit from the nozzle, there must be a kinetic energy. So this input, it is in the form of kinetic energy. The input is in kinetic energy and the output, it is in the power. That means the wheel is trying to move. So this is an input power in the form of kinetic energy and this is output power in the form of work. So this work will develop. So this work will develop. So so in this direction, how to find the work? What is the work? Work is the power. This power will develop. Work or power. So power will develop. So what is the power? Force into the velocity. So what is the power? Power developed by the wheel. Power developed by the wheel. Yeah, plate is what beta? Force. And this is force in, let's suppose this force is in x direction. So Fx only into the velocity u. And this force we have to find. What is this force? We have to find. So the force we have to find. Why? Because this is a relative velocity. Okay. So rho q discharge, the velocity is v minus u into. So this is your force. So if you multiply with this one, this is your power. Correct? So this is your force. This quantity is your force. And this will derived by the momentum equation. This is derived by the momentum equation. So this momentum into the velocity, this is derived by the force, momentum equation, velocity, force into the velocity is power, also called work. Okay. Okay. Now, so this is output. What is input? So input, it is in the form of kinetic energy and this is half m v square. M is what beta? Density is equal to mass by volume. Volume is what? Volume flow rate. M divided by volume flow rate. Area into velocity. Area into velocity. Area into velocity. So M is equal to rho A into velocity. And rho into A is your discharge. Yes or not? This is your meter cube per second discharge. Okay. So M is your rho into Q into velocity is V square. So this is your, so efficiency, it is your output by input. So what is output? Half. What is output? Output is your power. Power is rho Q V minus U into U divided by half rho Q V square. So this rho Q cancel. So this is what beta? 2 into V minus U into U divided by V square. Put all this value, that means 2, what is V? V is your 20 minus 15 into 15 divided by 20 square. So this is your approximately 37.5%. That's it. Okay? This is okay? So generally, this is nothing at all. This is the very fundamental things. So in the civil, the fluid mechanics is very fundamental, not go be in the deeper manner. So what is the confusion? If you go civil department, if you go civil engineering student, if you go to the deeper and deeper in the fluid mechanics, you are hamper the other subject. So what is the motivational story for the today's lecture? What we have to understand, it is not a matter to solve the problem or not. The matter is that fluid mechanics, it is a common in the civil engineering and mechanical engineering. I am humbly request that in the mechanical engineering, you have to go to the detail, but the fluid mechanics, you have to understand the fundamental concept only. Fundamental concept, okay? But in the fluid mechanical department, you must be have a go to the fundamental and also the nature of that particular things, the nature of the particular equation. Okay, beta? So today it is in depth up to that one in depth here, and we have to discuss from the tomorrow with the next questions for the next year, that means 2022. Up to that, thank you, bye bye, take care.